Today, we're making a vine screen lamp with a laser cutter. To design this project, I start by sketching the overall vine pattern with an app called Morpholio Trace. All of the vines will have a curved shape and move from one side of the lamp to the other. At some areas, they'll overlap, cross, or start a new branch. Once the general pattern and idea is complete, I move to a software called Rhinoceros and I start by using a previous lamp file that I designed for a Frank Lloyd Wright-inspired lamp. This screen lamp will have a similar structure. We'll start by adjusting the tabs and slots for the two internal square frames and the four sides. Instead of having two tabs on each side, we're reducing it to one and centering them. Then I import my vine sketch, scale it up, and move it so that it aligns with one of the sides. I take my time getting the sketch aligned because it'll be harder to go back to this step later. I turn off all my snaps for points and orthogonal tracking so that I could draw lines without having any guides pulling the mouse cursor. I use the curve line tool and place points along the outer area of the curves from the sketch. This part of the process might look simple right now, but this is only the beginning. There's a lot that we'll need to refine after the rough pattern is traced. When we're done tracing each end of the shapes, we can hide the imported sketch and see what we've drawn. There's a lot of jagged lines and overlapping ones which we need to clean up. To do this, I click on one of the curved lines and look at the points that I drew. I find the points that are pulling the curves and making them jagged and either move them to smooth out the curve, adjust the control point associated with it, or simply delete them. The goal is to end up with really smooth curves throughout the panel. When the curves are smooth, I draw a rectangle and offset it inwards, which will define the perimeter where the pattern will end. I use the trim command to delete overlapping lines. To make sure this design works, I extruded the shapes to match the 1/8 inch EcoBirch plywood that I'll be using to construct this table lamp and assemble the 3D model. I use the rotate and move commands and snap every tab and slot together. This is what the final model looks like without the thin screen layer which we'll have in the physical product. With the design file created, I applied protective paper masking tape to my darker EcoBirch plywood. I load up my laser cutter, insert 1/8 inch plywood, and start the cutting process. I've been enjoying the process of designing and making these simple lamps that come together quickly. The unique aspect of this type of lamp is in the pattern that we designed and a translucent paper that'll be glued to the backside of each panel. My favorite laser cut lamp style are actually the panelized ones that you can see throughout my YouTube channel, but I've been interested in exploring a style that's similar to shadow boxes. I'll be designing more lamps like this one. This vine screen lamp can be cut using two sheets of 1/8 inch plywood at 19 inches wide and 10 inches long, and each board took about 8 minutes to laser cut for a total of 20 minutes for this project. Once all the pieces are cut, I bring them over to my work table and remove the paper masking tape. I bring over trace paper and cut it down to fit over the pattern cutouts of the side panels. A simple trick that I use is aligning the panel and trace paper by using the grid on a cutting mat. It saves time from measuring with the ruler, drawing points with a circle, and cutting the paper. I apply glue around the perimeter of the pattern of one side panel and glue the trace paper onto its surface. I repeat this with all four sides. I also cut the trace paper to open up the slot for the bottom frame where the light fixture gets installed. Then I apply glue along one side of the bottom and top frames. I align the tabs with the slots of one side of the lamp and push it into place. I repeat this with the top frame. Then I apply glue to the opposite side and bring the side panel with the same tab and slot cutouts at the perimeter as the first piece. I align the slots of the panel with the tabs of the frames and push it into place. Now I turn the assembly over so that the empty side is facing up, and I apply glue between all of the tabs of the frames and side panels. I bring over the next side panel, align the tabs and slots, and push it into place. It takes a little bit of wiggling the pieces around, but the side tab should all snap together for a snug fit. I repeat this with the last side. Once the lampshade is fully assembled, I attach a typical lamp kit that you can get at a local hardware store or on Amazon. Then I install the light bulb and the project is complete. The asymmetrical pattern of the vines on each side of the lamp makes it visually engaging where your eyes move from one area to another as it tries to identify a regular pattern. It's like looking through a window on an old brick building that was overtaken by vines or peeking through the branches of a bush during a hike. If you enjoyed this project, check out my other laser craft videos and consider subscribing. I'll see you again next week.